I'm Ajay Uppal from Hughes City Corporation, and my topic of talk is massive machine type communications in 5G. And I'm going to talk about the challenges and solutions of 5G MMTC. So, 5G, as you all might be knowing, is a big buzzword in the industry. And as Sunil has already introduced, it's the next generation of mobile communication technology. Uh, it is not just about high data rates, it's an ecosystem of technologies which is going to cater to a wide range of use cases and requirements. Um, and it's going to impact a lot of industries, uh, businesses, agriculture, and the lives of people in general. So that's about 5G and MMTC, or the massive machine type communications, is a very important aspect of 5G, and I'm going to talk about it. So this is basically the agenda. I'll create a context of 5G of machine type communications. I will spend some time on the present uh, MTC technologies in the world, and some time on their shortcomings, and what are the shortcomings for which an MMTC is required. I will then spend time on the design considerations and challenges in 5G MMTC and some potential solutions. So without much ado, let's proceed on. So 5G, as we know that it's going to take care of a lot of use cases and requirements, but all those use cases and requirements can be grouped into one of the three categories or one of the three services. So the first is EMBB, or the enhanced mobile broadband, uh, which targets high data throughput of the order of more than 10 Gbps, high system capacity of the order of more than 1,000 times that of LTE, and a lot of a much better spectral efficiency than LTE, 3 or 4 times that of LTE. So its use cases are high-speed mobile broadband, virtual reality, augmented reality, gaming, etc. Ultra reliable, low latency services focus on the low latency and high reliability and high availability aspects. So the expectation is of the order of less than 1 millisecond of latency, and availability of the order of 99.9999%. So this is basically for mission critical use cases and mission critical applications. MMTC, which is the topic of today's discussion, is the massive machine type communication. It aims to provide connectivity to a huge number of devices uh, whose traffic profile is typically a small amount of data sporadically. So for them, latency and throughput are not a big concern, but the main concern is uh, optimal power utilization of those devices, because they are battery powered, and the expectation is that their battery would last uh, around 10 years or something like that. So this is an introduction. Machine type communication, or Internet of Things, it's basically about connecting devices without human intervention, uh, and those devices would typically generate some sort of data that would be sent to some cloud servers. Those servers would uh, analyze the data and take some sort of action on that. So these devices can be, fitness bands, smart watches, connected home appliances, smart city related devices like, lights and all that. So those sorts of devices are typically getting connected through MTC. So, so in terms of MTC, already a lot of technologies are there in the world which are competing with each other to provide services. These technologies typically can be divided into two groups. One is the non-3GPP or the proprietary ones. They are also called LPWANs. Uh, and On the screen right now are some examples of those. Zigbee, LoRa, InGenu, Sigfox, Weightless, and so on. These are some of the popular non-3GPP MTC technologies. So the main characteristic of these technologies is that they use the unlicensed spectrum. So cost-wise, they are cheaper to the user. Uh, I mean, infrastructure-wise, right now, their infrastructure is not present throughout the world. It's present at some locations only. Uh, they are not 3GPP standardized. They use open or proprietary standards. But yes, they have been around for a while, so they do have some sort of a early mover advantage. So that was about the non-3GPP ones.